All right, hello everyone. Welcome back to our final video on worksheet number 2. In this worksheet, we're going to go over problems 8 and 9, which deal with linear functions. Okay, so hopefully you've watched the previous videos, but if you haven't, actually this one can kind of stand alone. Um, so yeah, do watch the other videos because especially the one before this, covering problems 4, 5, 6, and 7, is complex stuff, so it would be a good idea to watch that one. But this one here, you're probably familiar with linear functions from previous classes, so uh, let's jump right into it. For problem number 8, it says each part includes information about a particular line. Identify the identify the slope and the y-intercept, and write the equation of the line in slope-intercept form. Okay, y equals mx plus b. So let's go ahead and just identify the types of forms that we have for linear functions. There are three. The first one is called standard form. And every single line can be written in standard form. That is ax plus by equals c. Okay, this one has the advantage that every single line can be written in this form. Form number 2 is called, let's call it slope-intercept form. The nice thing about slope-intercept form, which was given to us here, y equals mx plus b, is that you can very easily see what the slope of the line is and the y-intercept. Okay, so slope-intercept form is a very common one. And then the third form is called point slope form. Okay, so point slope form is one that I like. Um, The most common one, though, is slope-intercept form. Point slope form, it is one that is useful when you have a point, let's call it x1 comma y1, and a slope, call it m. Point slope form says that the equation of the line is given by this equation here, y minus y1 equals m times x minus x1. Okay, so um, let's Okay, so point slope form is just an equation that you can use when you have a point and the slope. And so it is useful. We will use it in one of the examples just to show uh, the different ways that you can do it. Okay, so let's go ahead and take a look at, okay, well, those are the different forms. We're going to put each of these equations into slope-intercept form. And then there's one other equation that we need to know, and that is how to find the slope of a line. So this is meant to be just a quick review of some of the stuff that you've seen before. So the slope of a line is given by m equals, if you're given 2 points on the line, call them x1, y1, and x2, y2, then the slope is defined to be y2 minus y1 over x2 minus x1. Okay, so that's everything that we need. We'll talk about parallel and perpendicular lines when we get to problems H and I. Okay, and so for this video, I'll be doing these highlighted problems. They are very similar to, A and B. Here we have a slope and a point, which are similar to C and D, C, D, and E, actually. If you have 2 points, you can find the line that passes through them, similar to F and G. And then finally, we're going to find the equation of a line who is perpendicular to a line with slope, or with equation equal to 1/4 x minus 7/4. And I put an m1 here, but this should really say y equals. And through this given point, -5 comma 3. Okay, so we'll do these. And this problem here is going to be very similar to H and I. All right, so let's jump into the first problem. We want to write each of these equations in slope-intercept form and identify the slope and the y-intercept. Okay, so if we start with a problem, let's start with, I'm going to call it just problem 1. 6x minus 3y equals 9. This equation is in standard form. To get into slope-intercept form, all we have to do is solve for y. Okay, so we have minus 3y equals negative 6x plus 9. I'm leaving the x term first because we want to be in y equals mx plus b. We want the x term to be first. And then I can divide everything by negative 3. So y is equal to 2x minus 3. That means the slope, m, is going to be equal to 2. And the y-intercept is going to be the point 0, comma, negative 3. Okay. The number coefficient of the x is the slope, and the other constant coefficient is going to be the y-coordinate of the y-intercept. The x-coordinate of a y-intercept is always 0. Okay, so 0, negative 3. All right, so there's our first answer. We have the equation in slope-intercept form, and we identified the slope and the y-intercept. Okay, so we'll put that aside here. Next, what if we have a slope that is given to be m equals negative 3 halves and the point negative 4, comma 7. And so in this problem, let's go ahead and, so we're given a slope and a point. What can we do? Well, we can plug all of this information in. This is x1, y1. This is an x and a y coordinate, and we have an m. We can plug this information in to the point slope form. So I'll do that. And then in the next example, we'll use the slope-intercept form. But for this example, you could use the slope-intercept form. We'll show how to do that in the next example. So y minus the y value of our ordered pair, 7, equals m, which is the slope, times x minus the x value. The x value is negative. We're subtracting that value, so we do have a double negative there. Okay, so we have y minus 7 equals negative 3 halves. Let me cancel out these negatives here so I can distribute the negative 3 halves at the same time. I'm going to get negative 3 halves times x. And then the positive 4 is going to be multiplied by a negative 3 halves. That is going to cancel. So the 2 goes into the 4. Well, we can multiply negative 3 halves times 4 over 1. On top, we're going to get a 12. On the bottom, we're going to get a 2. 12 divided by 2 is 6. One of the numbers is negative, so this will be a minus 6. Okay. And then finally, we want to get into slope-intercept form, where we want the y by itself and all the other terms on the other side. So I am going to get the y by itself by adding 7 on both sides. So y equals negative 3 halves x plus 1. That is our slope-intercept form. Our slope is negative 3 halves. That's known as the rise over run if you wanted to graph this. And the y-intercept, the starting point, if you will, is 0, comma, positive 1. And that's our answer. Okay. So if you wanted to graph this, just to kind of show what this is useful for, you can find the point 0, 1, and then rise over 1. We have negative 3 over 2. That negative we can consider as part of the numerator. You can consider it part of the denominator if you like. Either one is fine. Negative 3 halves is the same thing as negative 3 divided by a positive 2, or positive 3 divided by a negative 2. So however you want to think of it. So let's start with negative 3 over positive 2. That would be down 3 units. So 1, 2, 3, and then positive 2 in the run. So that would give us this point next. Or if you want to think of it as 3 divided by negative 2, that is rise positive 3, 1, 2, 3, and run negative 2. And so that would put us somewhere over here. And you can see that the same line is formed, no matter how you think of that, where you put that negative sign. Okay, so um, I don't have a graph paper here, it's just so this is a sketch, but if you had a nice sheet of graph paper, everything would just line up perfectly. All right, so there we have the how to find the equation of a line in slope-intercept form using the point slope form to find the equation of the line, and then we just solve for y. Okay, so let's go ahead and put that away. Mhm. Next, in this next problem, we're given 2 points that lie on the line in question. And so what we can do with these 2 points is say one of them is x1, y1, the other is x2, y2, and we can find the slope. M equals y2 minus y1, there's a double negative there, divided by x2 minus x1, 11 minus 3. And so what we get here is -1 plus 4, which is 3, and then 11 minus 3 is 8. Oh, this is not a nice number. 3/8, I mean, that's okay. So we have that our slope is 3/8. Now we can use the slope-intercept form to plug into it. Let's see, slope-intercept form says y equals mx plus b. So I can now plug in my m, and I have an x and a y value. I can use either of these x or y values to plug into my equation. So I'm going to plug in an x value. And as soon as I choose an x value, I have to choose its pair, its corresponding y value to plug in. I could have used the pair 3, -4, as long as I use both of those values, or 11, -1, as long as I use both of those values. So either pair is fine as long as I choose a single pair. Okay, and if I plug all of that in, the y value is -1, the m is 3/8, x is 11, and b is unknown, but I'm about to solve for it. Okay, so if you're used to doing it this way, you can do this. So -1 equals 33 over 8 plus b. So to solve for b, all I have to do is subtract 33 over 8. I'm going to get a common denominator. Right now, the denominator is 1, but let me go ahead and write this with a denominator of 8. So this is, if I subtract 33 over 8 on both sides, then I'm going to get b is equal to -8 over 8. Let me write it out. -8 over 8 minus 33 over 8, which gives us a negative 41 over 8 as our b. And so we have m, we have b, so our equation of the line is y equals m 3/8 x plus b. Plus b is since b is a negative number, I'll put minus 41 over 8. That is the equation of a line in slope-intercept form. The slope is 3/8, we already knew that. And the y-intercept is 0, comma, -41 over 8. Now, this one came out a little bit ugly, only because the numbers just, that's just how it came out. We would get the same equation if we had done it in the point slope form. So, you can use the point slope form or the slope intercept form. This one here, I kind of want to check just to make sure that it goes through the points 3, -4, and 11, -1. 3, -4, and 11, -1. Let's check. 3/8 x minus 41 over 8. We'll check on desmos.com. 3/8 x minus 41 over 8. Let's see, y equals 3 over 8x. Nope, I want the x to be minus 41 over 8. Okay, just like that. And then what were the points? They were 3, -4, and 11, comma, -1. So 3, -4 is on the line, and 11, -1. Yeah, looks good. All right, nice. So there we have an example using just the slope-intercept form the whole time. not using point slope form. I would advise you to do this problem again using the point slope form to see what the difference is in solving it. And the previous one that I did using the point slope form, try using slope intercept form only by plugging in the slope and in place of x and y, plugging in the coordinates of the point and then solving for b. You'll see that you get the same answer in both cases, but it's just a little bit of a different way to solve. So feel free to look at that. Okay, and then finally the last one. The last one is a problem about um, perpendicular lines. There's one about parallel lines as well, but I'm going to do the perpendicular one. Basically, we want to find a line that is perpendicular to, and then I gave a different line here, to this line here, y equals 1/4 x minus 7/4. And so usually people remember what do, how do the parallel lines compare in terms of slopes? The slopes of parallel lines, if they're parallel, they have the same slope. So if we were looking for a parallel line, we would use the same slope as this line here with the 1/4. But we're not looking for a parallel line, we're looking for a perpendicular line. So the slope of a perpendicular line, I'm going to call m sub, I'll call it m sub 2 or something. The other slope, m sub 1 is 1/4. The slope of this line is 1/4. Okay, we know that. But what's the slope of our second line, the one that we're looking for, that's perpendicular to this first line? Well, it's actually going to be the reciprocal 4/1. It's the negative reciprocal of the other line. So -4 if we want to reduce it. M sub 2, the perpendicular line has slope -4. That's always true of perpendicular lines. Their slopes are opposite reciprocals of each other. Okay, so we now know the slope. And now we want to find the y-intercept. So we know the slope, we have a point. Which method do we want to use? I'll do both methods. I'll show you both just to give a fair shake to each of them. So let's start with the slope intercept. No, the point slope form. I like that one. Either one of them is fine, but let's go ahead and use this one. This one's so nice because all you have to do is plug in. Just plug in your slope, -4. So y minus, the y value is, I'll put an arrow. The y value of this point here is, so that's y1, and that's x1. 3, so y minus 3 equals m, which is -4, times x minus the x coordinate, which is -5. There's a double negative there. Be careful with the double negatives. They do come up sometimes. Don't leave one of the negatives off. So we have y minus 3. These negatives will cancel. So that's a x plus 5 in the parentheses. We'll distribute the -4 to get equals -4x minus 20. And then we'll just add 3. We're going to solve for y to get it into the slope intercept form. And so we have y equals -4x minus 17. That's our answer. Okay, that's it. I'm going to change the color here and do it using the slope intercept form, y equals mx plus b, just to show the other method using the same problem. Just to not show, because in the other problem that I did with a slope intercept form, that problem was more complicated. So it made the method look more complicated, but it's about the same amount of complexity. Okay, so we'll plug in. So what we do is we plug in for y, we plug in for m, and we plug in for x to solve for b. Right now we have an x and a y value, and we have an m value, but we don't have a b value. So we'll plug everything in. The y is 3, the m is -4, the x is -5, and b is unknown. So we multiply to get 20. We subtract 20 on both sides. So b is equal to -17. And so now we can write y equals mx plus b. The b is negative, so I'll put -17. Notice we get the same answer. Took about the same amount of steps. 1, 2, 3 steps, and then we write our equation. 1, 2, 3 steps, and we write our equation. It's about the same. Okay, so that is Problem number 8. Um, Problem number 9. Yeah, let's go ahead and just do it. We'll do it in the same video. Okay, so here we're talking about the candle height and how fast the candle just changes in height as it kind of deteriorates, as it burns away. And so I have this nice little figure here that's just wanted to mention. It says, before alarm clocks existed, people used nails attached to candles to ensure they woke up on time. They knew how to calculate the burning time and place the nail in the right position. When the candle melted, the nail would fall, make a noise, and wake its owner. Okay, so I've heard of people doing this. They'd fall asleep and then, something would, after a while, that one of these nails would fall and wake them up. And so old school alarm clock. But you needed to know a little bit about how fast these nails are going to, or how fast this candle is going to burn away. And so that's what this problem talks about. So we'll just do one of these. I'm just going to do part A, and then part B, I'll leave it to you because it's very similar. So let's go ahead and take a look. The height of a lit candle changes at a constant rate and can be represented by a linear function. One candle has a height of 8 inches after 2 hours, so 8 inches after 2 hours, and a height of 6.5 inches after 5 hours. What is the constant rate of change? Constant rate of change. What is the starting height of the candle? And what is the height after 7 hours? Okay, so let's see. How do we organize this information? Well, usually we're going to put the independent variable. So this is going to be, in terms of ordered pairs, there's going to be a time value, which you can think of as the x value. And a y value will be, y is usually dependent on x. So here, t, the time, is going to be the first coordinate, and then the second coordinate is going to be the height at some time t. Okay, so if we want to use x and y, that's fine. But we should order these, the x values are going to be the time values, and then the y values are going to be the height values because they're not given in order in this problem. But it would make most sense to say that, and I'll put here time in hours is going to go in the first coordinate, and then height at time t, and this is going to be in inches. Okay. Okay, so the time in hours, after 2 hours, we're told that this is the candle is 8 inches tall. And so, you know what, I'll actually even organize my information. You could write them as ordered pairs, or we can write them in a table, however we want. Let's see. So x and y. This is x hours and y inches. Okay, so after 2 hours, we're at 8 inches. And then after 5 hours, we're at 6.5 inches. So what is the constant rate of change? The constant rate of change, that's known as the slope. Okay. And so all we're going to do is find the slope. M equals y2 minus y1 over x2 minus x1. And if it helps you to try to keep your information organized, label these, x1, y1, x2, y2, because you don't want to mix them up. If I did 6.5 minus 8 divided by 2 minus 5, that would be wrong. It would give me an incorrect answer. So I can subtract here. 6.5 minus 8, that is negative 1.5. And then 5 minus 2, that is 3. And so what I get is if I multiply the top and bottom by 10, just to get rid of the decimal, we know about multiplying by 10, that just moves the decimal place over one place. That's negative 15 divided by 30. And we can see that's a half, right? If we divide by 15 on the top and on the bottom, we get negative 1 over 2. And keep in mind that when we do the slope, it's y2 minus y1 over x2 minus x1. If y has units, like in this case, which is inches, and x has units, which is in this case hours, then this negative 1/2 has units assigned to it as well. And that is going to be in inches. This is negative 1/2 inches per hour. Okay, so what this is saying is it loses 1 inch every 2 hours. Okay, and you can actually write negative 1/2 if you want to a different way. You can write this as, well, this is negative 0.5. That's negative 1/2. So we can write it as negative 0.5 over 1 to describe that we actually lose half an inch each hour. Okay, so half an inch each hour is the same thing as 1 inch every 2 hours. So however you want to think of that, I'll use negative 1/2 as my slope. So for part 1 here, the constant rate of change is losing. The losing is going to represent the negative sign, losing 1 inch every 2 hours. Okay? Or half an inch every hour, or 2 inches every 4 hours if you want. Okay, so there we go. What is the starting height of the candle? Well, the starting height is going to be essentially the y-intercept. And so if we now know that m is equal to negative 1/2, and one of the points is 2, 8, let's say, we can use either of the points, we can find the slope-intercept form, y equals mx plus b. B will be that starting height. So let's do, yeah, I'm going to do y minus y1 equals m times x minus x1. So plug in my m, plug in my, my x, and plug in my y. So y minus 8 equals negative 1/2 times x minus 2. So if I distribute this negative 1/2, I have, and, yeah, okay, we'll wait till the next step. I was going to say add 8 at the same time, but well, I'll just wait. So we have y minus 8 equals negative 1/2 x. Negative 1/2 of negative 2 is positive 1. And then finally, if we add 8 to both sides, then I get y is equal to negative 1/2 x plus 9. That 9 here, remember that x is the time in hours. So if I want to know, just to verify that this was the starting height of the candle, that it is in fact the y-intercept, I can find, evaluate this. Y, this is, a function of x. Y of x is negative 1/2 x plus 9. If I want to know what the height of the candle was at time 0, at the when I started, I can find y of 0. This is negative 1/2 times 0 plus 9. This is negative 1/2 times 0, 0 plus 9. This is 0 plus 9, which is 9. This is a y value, which has, it represents a height at time t, at time 0 in inches. So 9 inches is the starting height. Okay, so I'll write that in a sentence. The starting height of the candle was 9 inches. And is this correct? Can we check this? Well, yeah, I guess, because it says after 2 hours, it's 8 inches. And we know that it's losing half an inch each hour, or 1 inch every 2 hours. So after 2 hours, it's 1 inch less, which is um 2 hours, it's 1 inch less. That's 9 minus 1, which is 8. Yep, that makes sense. That checks with our table here. And then 2 hours later would put us at 4 hours. It would lose another inch and be 7 inches. And then half an hour later, oh, sorry, one more hour later would be 5 hours. It would lose half an inch in that time. 7 minus a half is 6.5. So everything is checking out just fine here. Okay, so this is the correct answer for part two. So now we have part three. We actually have a function now, y of x is equal to negative 1/2 x plus 9. This says that the height, well, y of x, the height, and if you prefer, just in case maybe somebody's interested, we can call this y of, or actually, we can call this h of t if you prefer. The height at time t is negative 1/2 times the time plus 9. So the time is going to be multiplied by negative 1/2 because the time in hours, as the time grows, we're getting more negative 1/2s taken. We're getting more 1/2s taken away from in inches from the original 9 of the candle. Okay, so the last question was, what is the height after 7 hours? What is the height after 7 hours? So h of 7 is negative 1/2 times 7 plus 9. We're going to get a negative 7/2 plus 9. We can get a common denominator. Oops, common denominator is 2. And so we have negative 7/2 plus 18/2 equals 11/2, which is approximately exactly 5.5 inches. So the height after 7 hours is 5.5 inches. We write the sentence to demonstrate our understanding. Okay. And hey, actually, we could have just seen it here. After 7 hours, we said in 2 hours it drops an inch, 5.5. So there's multiple ways to figure this out. But what if I asked you, I would not really, well, I wouldn't want to accept this by itself as the answer. We really should show, find the function, evaluate the function at 7, because I could ask, excuse me, I could ask you a different question, like, what is the height after, let's say, 70 or 7.35 hours. Okay. And it becomes a little bit harder, or what is the height after pi hours, right? We can kind of make this a little bit more complicated. Well, this is no problem for our function. We can just plug in pi right there, and that would give us our answer. Okay. Um, Yeah, so the numbers can be made more complicated. These are kept kind of simple since we don't have calculators in this class. Um, so we do want to see the work for this solution. Okay, and that is it. Try the other problem on your own, and then bring your answers to class, and we can check those out. Okay, remember to comment on the video, leave a like, and if you want to see something specific, leave a comment, and if I have time, I can get around to that. All right, we'll see you in the next video. For next video, will be for worksheet number 3. Yeah. All right, see you then.